Hi, my name is Borja Muñoz, and I'm a product manager at CARTO. First of all, I would like to thank Databricks for organizing this summit. And today, I want to show you how you can unlock Geospatial analytics use cases by combining CARTO and Databricks. First, a brief presentation about CARTO. CARTO is a location intelligence platform. Our main goal is to unlock the power of spatial analysis. Currently, we have more than 500,000 users, and we have a team of more than 150. And we are one of the leaders in the field of spatial data science. Why does spatial analysis matter more now than ever? Because we have new end users. Traditionally, spatial analysis has been a field dominated by GIS specialists or GIS analysts. But now there are more users that want to take advantage of spatial analysis. For instance, we have business analysts or product managers. We also have data scientists trying to use spatial information, and decision makers that are using spatial information as one of the key fields for their decision. We also have new data streams that weren't available before now. For instance, we have human mobility information coming from telco companies, or we have IoT hardware information or transactions information coming from credit card companies. Also, with cloud computing and the new distributed computing platforms, new analysis are possible. So we can implement new optimization algorithms for spatial prediction, and we have a whole new field called spatial data science. With the combination of CARTO and Databricks, we can solve some of the most frequent challenges that you can find when you are trying to use spatial information and do analysis with it. The first challenge is to be able to do spatial analytics at a scale. So usually, spatial analysis have been done by GIS analysts using powerful workstations, but you are limited by the capacity or the resources of the workstation. And now, using a platform like Databricks, you can scale computation in a cluster of machines, so you can work on very large data sets. The second challenge is related to information that is in silo database system, and you want to combine and to enrich the information. This is something that is quite easy using CARTO and Databricks, because you can use the CARTO SQL connection feature to access the information in your CARTO database and then combine it with the information in your Databricks Delta Lake. And finally, the third challenge is related to data exploration. Usually one of the first tasks that a data scientist does is to explore the data set. And if the data set has spatial information, you need to be able to explore it in an interactive map. And this is something that you can do with CARTO and the CARTO Frames package within a Databricks notebook. What does the architecture look like if you are using CARTO and Databricks? So starting from the left, we see that CARTO has a relational spatial database with the spatial information. Then you can read this information from the Spark cluster in Databricks using the direct SQL connection. You have two options. You can store the information in the Delta Lake for later processing, or you can directly use CARTO frames for doing visualization, enrichment, or analysis. With both options, at the end, you can write the results back to the CARTO spatial database. So we have mentioned two of the main CARTO products or CARTO features. These are the direct SQL connection and CARTO frames. Direct SQL connection lets you connect to the CARTO database from the Databricks cluster and rewrite information very easily using Spark data frames. CARTO frames is a Python package that you can use for enriching, analyzing, or visualizing geospatial data within your Databricks notebooks. In more detail, with a direct SQL connection, we can easily create a Spark data frame by just using the spark.read.format method, as you will use with any other JDBC regular connection. And with CARTO frames, you will install in your Databricks notebook as you will do with any other Python library. Then you need to set up your default credentials, that is your CARTO username and your CARTO API key. And finally, you can read information easily from a CARTO dataset into a GeoPandas geodata frame using read CARTO. So when should you use direct SQL connection, or when should you use CARTO frames? You should use the direct SQL connection when you need to perform data engineering tasks that are not suitable for relational databases or that are difficult when using relational databases. For instance, if you want to do a white-to-long transformation. You should also use the direct SQL connection if scalability is an issue. If you need to perform spatial analysis over very large data sets, you need to use the direct SQL connection to be able to use Spark data frames and then use the full power, the full resource and capacity of your Databricks cluster. And then you should use CARTO frame if you want to do data exploration, interactive map, you want to visualize your data. If you want to enrich your data sets using CARTO Data Observatory, you should also use CARTO frames. And finally, if you want to do some spatial analysis, like generating isochrons or geocodings, CARTO frames is also the way to go. Now we are going to talk about use cases. We will start with generic use cases, and then we will move to industry use cases. Starting with generic use cases, the first is data engineering. We are going to use Databricks for collecting and preparing the datasets that we will later visualize or analyze using CARTO. If we are talking about the data visualization use case, what we want to do is visualize in a CARTO map the information that we have, and we want to do it within a Databricks notebook because it's the environment that we are using. And finally, we have the data analysis use case where we can take advantage of the CARTO features for spatial data science without leaving your Databricks notebook. We are now going to focus into some industry use cases. These use cases are available in our website at carto.com/industries, where you can find these use cases and also use cases for additional industries. Starting with logistics, logistics companies are using spatial analysis for several use cases. One of them is route optimization, where we want to identify the optimal routes and optimize them by using spatial information. It is also used for pick-up and drop-off site planning. So for instance, if you want to install or to have self-serve lockers and you need to decide where is the best location, you need to be able to predict demand using spatial modeling. And you can also use it for fleet management. So for instance, if you want to visualize where your fleet assets are or how you can optimize their activity, you can also use location data streams like traffic data or weather data. Another industry where spatial analysis is being used a lot is telecommunication companies. They are using spatial information for creating data products and for doing data monetization and selling these products to B2B companies. They are also using spatial analysis and spatial information for planning their network deployments. So they need to be able to look at market requirements, to look at potential customers, and they are going to use spatial information for that. And another use case is smart cities and IoT, where they are going to currently They usually provide the communication platform for the IoT hardware, the IoT sensors, but they can offer more value if they also provide analytical tools using spatial information. Financial services is also one of the industries where spatial information and spatial analysis is being used in key use cases. One of them is branch consolidation for consumer banks, where they need to decide which is the branch they are going to close, and for that they need to be able to monitor site performance using spatial modeling or spatial analysis. Another typical use case is ATM location optimization, where they need to decide where to locate the ATMs in order to maximize the transactions and the revenues by looking at demographics or socioeconomic profiles. And for instance, credit card companies are also using spatial analysis for doing transaction analysis. So they know not only the where, but also the why behind consumer spending habits. And this information is really essential for the marketing and retention departments. We also see a lot of use cases within the consumer packaged goods or fast-moving consumer goods sector. They are using a spatial analysis for key functions like distribution management or supply chain networks. They need to ensure that they stay in stock. And in order to do that, they need to use spatial information to ensure that they have a really robust distribution management system. They are also using spatial information for other use cases like territory management, where they are designing territories that are better balanced in order to optimize or to improve the field sales performance. And finally, the last industry we are going to talk about is healthcare and pharma. In healthcare and pharma, the companies are using, for instance, healthcare factor analysis, especially the insurers and the public health authorities, to ensure that they allocate their resources in a very smart way, looking at information like data streams. And also they are using spatial analysis for doing site planning when they want to open a new hospital, a new clinic, or a new vaccination center. They need to decide which is the best location so they can maximize the return on investment. And for that, they will use health data, catchment areas, population data, that all of them have a location component. Now we are going to see a real-world example. We will see how we can use CARTO frames with the data observatory and also with spatial analysis features to deliver some very interesting insights. The first thing you have to do is to install the CARTO frames library. We are going to do it using install PyPI from the dbutils library. Next, we need to set up the credentials for accessing our CARTO account. You can use CARTO frames without having a CARTO account, but some of the functionalities like data enrichment through CARTO Data Observatory won't be available. We are going to look at the target store locations in the United States, and we'll try to get some insights using visualization and spatial analysis. First, we create a pandas data frame by reading the CSV file, and then we convert it to a GeoPandas geodata frame, creating the geometry column that will store the location from the longitude and latitude columns. After we have our geodata frame ready, we can quickly visualize the information on an interactive map by creating a layer object. Now you can easily write the information from Databricks to your CARTO account, calling the toCarto function with the geodata frame and the name for the dataset we want to create. Then we read the data again, but this time from our CARTO account to create a geodata frame. And now we are going to create a map taking advantage of CARTO Advanced Visualization capabilities. First, we are using the color category style helper function to create a crop left map where each target store will be assigned a color depending on the subtype attribute. Our visualization will also include a pop-up showing the store name and the address, and we will add two different widgets to show the number of stores in the current view and the distribution of stores depending on the state attribute. Finally, we are adding a map legend and we are selecting the dark matter base map. As we zoom in, we can see the different stores with a color base and the subtype attribute, and we can see how the values on the widgets are updated. We can also publish our visualizations to our CARTO account so they become available by just using a URL. We can protect this URL with a password if we want to. Let's see how we can generate some interesting spatial data science insights. Let's start by creating isochrons. We'll generate areas within a 10-minute drive for each store location. In order to do that, we just need to use the CARTO Data Services API through CARTO frames to create an object to call the isolines service, and then call the isochrons method passing by the geodata frame with the store locations, the drive time in seconds, and the mode. There are also additional location data services like geocoding service to get locations from addresses or place names. The result for this operation is a new data frame with a polygon for each store representing the drive time areas. Then we can write the results to CARTO, or we can create a visualization showing the polygons. If we zoom in, we can see the polygon here. Probably the target store is around here. We can take advantage of Spark distribution features to scale the computation and be able to process simultaneously several isochrons or geocodings if we have a very large dataset. For instance, we could write an UDF function that will process one store at a time. Probably the most useful feature is being able to do data enrichment using the datasets from CARTO Data Observatory. First, we take a look at what are the dataset categories available. If we want to look at demographic data, we can pull out all the demographic datasets available. Then we select a sociodemographic dataset from the American Community Survey, and we take a look at the area covered by this dataset, in this case, all the US. To do the enrichment, we need to select one of the variables in the dataset. The first thing we do is to retrieve the available variables. We can also filter the list. Here we are pulling out all the variables that include the word income in the description column. Now we select two variables, median household income and total population, and use them to enrich our dataset that contains the drive time polygons. It is very easy. We just need to call the enrich polygons method and we will get a new geodata frame with two new columns at the end representing the median household income and the total population for each drive time area. We currently have more than 7,000 datasets available in the Data Observatory. Some of them are premium datasets and you need to get a subscription first, but we also have public datasets like the ones from the American Community Survey or population datasets with worldwide coverage like WorldPop. Now we're going to create our final map. We are going to join the enriched drive times polygons with our original datasets with the stored locations. After that, we are going to create a visualization that will assign a different color to each polygon depending on the median income attribute. We will define a pop-up that will show the store name and address and also our two new columns representing the median income and the total population. And finally, we will add 4 widgets to show the number of stores in the current view, the store distribution based on the state attribute, and 2 histogram widgets showing the distribution of the 2 new variables. So this is the end of the demo. You can generate pretty interesting insights from your Databricks notebooks by using CARTO frames with the CARTO Data Services API and the datasets from CARTO Data Observatory. So thank you. Thank you very much for attending this session. I hope you find the content interesting. Please don't forget to rate and review the sessions. Thank you very much.